Hi, welcome back. So today again, this video comes as a question from a subscriber. And the question is, so on the GMGC, the Global Microbial Gene Catalog, we make available nucleotide files for a lot of subcatalogs. But how do you get the corresponding amino acid versions? And so let me just show everyone what I mean before we get that. So here I've already gotten this GMGC 1.0 data folder, and let's check the subcatalogs. You can also get everything that's here. You can get it on the website as well. So I'll put the link to that in the description, as well as all of the code and everything we're doing here today. But as you can see, there's many of these GMGC 1.0, for example, marine, mouse gut, pig gut, and all of these different subcatalogs. And then, 95 non-redundant. And then there's two variations here, the full one and the one no rare, meaning it does not include any rare genes. So often the rare genes, as the name says, they're rare. So if you don't want to deal with such large files, sometimes the non-rare are a convenient way to do it. But as you can see, there are all of these are FNA, which is a convention we use to denote that these are nucleotide versions. And this is the important thing, so let me first just get, and I'm going to use here the dog gut one as an example. So when I run here, because I've already prepared this ahead of time, the git nx cat command does nothing. It just, the file is already there. So as you can see, these are nucleotides. So here ATG, so you see the start codon. But how do you get now the corresponding amino acid versions? And so I'm going to show you, and there's many ways of doing it. The important thing to understand is that each of these sequences, you just need to translate it. There's no need to run any gene detection. These are already the gene sequences there. So you can do it in many, many different ways. Let me just fix here the colors. You can do it in many, many different ways. So here I'm just showing you how to do it using BioPython. Okay, I'm gonna start here importing from bio, importing seq. Seq might not be needed. I'm gonna import seq.io to be able to read the file, and then I'm gonna start by opening this output file, and then using seq.io parse. And here, because it's a JZip file, I need to open it. We're using JZip. I need to open it in. And here you can see I'm opening it in read RT. So this RT is read mode and text mode, and I'm saying it's a FASTA file. Okay, and this is really only the only tricky bit in this code, because then it's absolutely trivial, because BioPython has this built, returns this sequence object and it has this method called translate, which just returns a different sequence object that's the translated version. So really here, all of the complexity is actually hidden inside this translate call. So we can just call translate, and now we have here I'm saying we have the S for the sequence, and now we have the SA for the amino acid version. And now I'm going to write it out, and here I just write it out using this very compact Python syntax. Oops, I should add here for FASTA. So the header line with the greater than sign, the ID of the sequence, a new line, and then the sequence and the new line. And that's basically it. And if I now run translate, I'm going to run it. We can see that file is still being generated. But now if I check, yep, here we have the files, the unigene IDs, and now we have nucleotide versions, starting with the methionine, that start codon. So that's it. There's other tools that can do this translation as well. I've shown it with BioPython. Everything's in the description below. Any questions, feel free to comment, get in touch. And if you're watching this at the very beginning of April 2023, and you happen to be in Paris, I'll be in Paris next week, and I have a couple of days, the 5th and the 6th. So if you're there, feel free to get in touch, and we can get coffee and talk science. But until next time, I hope to see you soon. And please subscribe and tell other people about our channel.